Alright, copying the hard drive and allocating the hash code. The next morning, Rupert gazed at the hard drive that was sitting on his desk next to his Rolodex. Right then, how do we see what's inside it? He asked Gloria. First, it's really important that the evidence we collect is forensically sound. That is, that it is obtained in a rigorous way that is acceptable to the courts. That should be acceptable to the courts. Alright? So the first thing we will do is to make a copy of the hard disk drive. As you know, data is represented by bits in computer storage, and we are going to make what is called a disk image of the hard drive. That is, we are going to basically copy it bit for bit. This is a process called dead system imaging, because we have removed the hard drive, the hard disk, from a switched off computer. This is called dead system imaging. Oh, okay, but it would take a while though, right? Take a look on that hard drive. Can you see there where it says 4 terabyte? What that means, there are 4 terabytes worth of bits to copy over, one at a time. And remember, each terabyte is 10 to the power of 12 bytes. Each byte has 8 bits. So you do the maths. How many binary digits, zeros and ones, are there on a 4 terabyte hard disk? So, at the same time as we copied, we are going to ensure that the image cannot be accidentally changed in any way. We're going to use a write blocker for that. It is a piece of software that makes the image disk read-only. Then we can work on extracting the data from the image, leaving the original hard drive untouched. To be sure, we will seal it in an evidence bag as soon as the copy is made. But if we're going to present evidence based on our analysis of a copy of the hard drive, how can we prove that it is a true copy? Asked Rupert. It's a very good question. How can we prove that this copy is the true copy? The piece of software that I will use to make this disk image will also run an algorithm that calculates a number called a hash code from all of the zeros and ones on the original disk. This hash code provides a single number that is much smaller than the total number of bits on the disk. Once we have made the disk image, we will use the same process to calculate the hash code for that too. If the hash codes match, we can be certain, or virtually certain anyway, that the disk image is a true bit-for-bit copy of the original disk, which means that we can do all of our investigations on the image disk rather than the original disk. This means that we are in no danger of compromising the original evidence. If we have to present our findings to a court, the hash codes will prove that we worked on an exact copy of the original disk. And if there if there is any suspicion that we might have changed the disk image while we were examining it, the judge can order the hash code of the disk image to be calculated again and compared to the hash code of the original sealed disk drive to check that they still match. So how is this hash code calculated? Asked Rupert. Good question. The algorithms for creating good hash codes are very complex, but I can give you a flavor by considering a much simpler hash code algorithm, replied Gloria. Say the original disk only contains a binary representation of the name Tam. We could reduce this to a single number by adding up the ASCII codes for T, A, and M, which gives us a hash code of 84 plus 65 plus 77, which equals 226. Suppose now an unscrupulous forensic investigator tries to change the data on the disk image to Sam in an attempt to get Tam off the book. The court orders the recalculation of the hash code of that disk image. It will now have the value 83 plus 65 plus 77, which is 225 instead of 226. And this, of course, will not match the hash code of the original disk in the sealed evidence bag. So the judge might rightly be suspicious that a forensic investigator has changed the evidence. Rupert thought hard before saying, but there is a big problem here. What is the flaw in this hash algorithm? Think anagrams. The problem with this algorithm is that any anagram of the original word will have the same hash code. So if, for example, the crooked forensic investigator changed Tam to Matt, the hash codes will still match. And that's a problem.